Let's talk about union and intersection of sets. So a set is just a group of numbers. I can give you a specific list of numbers that I want in my set, or I can give you an inequality for you to see what the set is. Either way, if I have multiple sets and I want to take the union, that means I want you to list any and all numbers that are part of either set. It's an either or problem. If you see a U like this, that means we are looking for the union. So I want you to tell me every single number that is in either set. On the other hand, an intersection uses this notation. I think intersection, just pretend it's, I guess I should have written the capital N. Intersection. Intersection, either way, it is only what they have in common. So these are the and type problems if you do compound inequalities. So for intersection problems, it's just what they have in common. If they don't have anything in common, not even a zero, then you write the empty set. And so the notation for the empty set is a zero with a line through it. There's no number in there, there's not even a zero, there's not a one, there's nothing. Let's do some examples because I think that may make a little bit more sense when you see examples. So example 1. Given that A is the set 1, 3, 5, 7, 9, and B is the set of numbers 1, 2, 3, 4, 5, find A union B. If you don't have these pieces memorized, I think of this union sign as an open cup, and so it's open so I can throw everything in there. So A union B means any and all numbers that were in either of these two sets. So I'm going to list everything in A, and then list anything in B that wasn't already listed. Like my 1's listed, I need a 2, my 3 is listed, I need a 4, my 5 is already listed, and that's everything. So it's a union, it's an open cup, I can throw every single thing I have in there. You should probably reorder this from smallest to largest, but that's your union. On the other hand, my intersection, I think of it as if I turn, think of hungry hippos. When you close their mouth down on the balls, it cuts off everything else. So it's just what's underneath the mouth. So it's just what's underneath this, I don't know, think of it as an upside down basket or something. So it's a little bit more selective. So in intersection, you only care about what they have in common. It's got to be in both sets. So notice they both have a 1. So that's going to be part of my intersection. They both have a 3. They both have a 5. There's not a 7 or a 9 in B, and there's not a 2 or a 4 in A. So that is my intersection. And I wanted you to see an example here. Let C be the set 2, 4, 6, 8. So now let's find A intersection C. So what do A and C have in common? Nothing. So that is when you would say this is the empty set. Let's do an example with set notation because you're more likely to see this rather than specific numbers written out. Set notation just has this X here. It's telling you we're dealing with X's, and specifically we want the X's all that are less than 4. So really it's just giving you the inequality written a little bit fancier. So for set A, we want all of the X's that are greater than 2. And for set B, we want all of the X's that are less than or equal to 6. It helps me to put this on a number line and see where everything overlaps and where it's double shaded and everything just in general. So I'm going to do that. Make sure you put your numbers in order from most negative to most positive. So for set A, X is greater than 2. It's all of these numbers. Open circle for greater than. And greater than, I want more positive. For set B, X is less than or equal to 6. So it's a closed-end dot because it's or equal to, and it's less than or more negative. All right, union means anything that you see that's shaded, anything that's in A and anything that's in B works for us. So in this case, my entire number line is shaded. It doesn't matter if it's blue or if it's red, the entire number line has shading somewhere. Even right here where I have this open circle over the 2, it's got the shading from the blue, so everything's shaded in, which means this is all real numbers, or from negative infinity to positive infinity. Okay. For intersection, remember, is more exclusive. It's just what they have in common, or just where they overlap, or just where it's double shaded. So it's only double shaded right here, from 2 to 6. We can write that in interval notation. It's not double shaded at 2 because this open circle implies we haven't started shading yet, so I need to put a parentheses, but it is double shaded at 6. This closed-in circle implies we are shading at 6 from the blue, and obviously we're still shading at 6 from the red. So there's our intersection. And to write part A in interval notation, we should use that. Let's do one more example of that. I'm going to write my number line. I have the numbers 5 and 6. A is the set of x's where x is less than or equal to 5. So less than or equal to means closed in dot, and less than or more negative than 5. B, x is the set where x is less than or equal to, less than is more negative, so shade to the negative direction, than 6, and it's or equal to, so I shade in my dot. All right, find A union B. It's an open basket. I can throw everything in, anything that I have that is shaded in general on this number line. So I have double shading here, so that means it's shaded. I have all this shading till I get to here, and then this is not shaded anymore. So my interval notation would be from negative infinity all the way to 6, and put a bracket because it is shaded there with that closed dot. So I have shading everywhere on this left-hand side of my graph. You can have multiple places where it's shaded with gaps in the middle. That's okay, which would just mean you'd have multiple intervals here. All right, well, what about the intersection? Intersection's more exclusive. It's just where they're overlapping, just where it's double shaded. So in this case, I'm only double shading right here. From negative infinity to 5. Infinity is always a parentheses, and 5 has a closed-in dot, implying that we are shading at 5, and we're shading with the red at 5 also, so that means to be a bracket. We are including 5.